Yeah, there we go. Hello, hello. Okay. I don't know what happened. I mean, my internet went out. It sucks that it created a new stream. So I guess the URL changed. Hey, what's up, Lon? Wait up, I need to YouTube Studio. This internet man. Go live. There you go. Hello, just joined. Hey, I was streaming before, but my internet went out. Wait, let me make sure my... Yeah, it's working well. Okay. Hello, welcome back, people. So unlucky. Anyways. We allocate this bk result is equal result this, just grab data, render, and render here, and assert that result is equal to bk success. Create descriptor sets, failed to create descriptor sets with error as and string bk result. Good. What is your eyes? It looks so good. It's Windows. Hope you like it. Anyways, yeah, people can't believe it. But this is just a window manager. You still have the taskbar here if you hover it. So after creating the descriptor pool in it, Vulkan, create descriptor pool, create descriptor never mind. Where is it? Create descriptor pool here. We need to create the descriptor sets. Cannot create descriptor sets. And this needs to be added on here right after create descriptor pool. This is so verbose. I thought creating a descriptor would be much easier. I thought it was Linux could work well again. You don't need to explicitly clean descriptor sets because they will be automatically freed when the descriptor pool is destroyed. The code to bk allocate descriptor sets will allocate descriptor sets, each with one uniform buffer descriptor. So we just need to destroy The descriptor sets have been allocated now, but the descriptors between still need to be configured. We'll now add a loop to populate every descriptor. Yeah, that's what I imagined also. First of all, descriptor pool. Oh, we're not freeing it. I wonder where do I do this? So right before the graphics pipeline, I'm guessing. Render descriptor pool. This. And if render dot descriptor sets set layout only, right? It's not null either. This is okay. Then we do that. Render and null and Simon. Wait. Simon, what am I doing? Render null. Okay, good. But the descriptor routine still need to be configured. Now populate every descriptor, but this where? I guess on create descriptor sets. Yeah. Allocate descriptor sets, and then for each of them, descriptor buffer info. Not only that, and then you have to create it, right? So this render dot data size of range, of course. Descriptor that refers to buffers like our uniform buffer descriptor configured with a. If you're overriding the whole buffer like we are in this case, then it is also possible to use the bk whole size value for the range. The configuration of descriptors is updated using the bk update descriptor sets function, which takes an array of bk write descriptors set struct as parameter. Right, and that's the set that we are updating, so remove that. Oh wait, there's another one. Okay, so we are resizing that, right? Descriptor sets, yeah. We resize it, but we don't set it. The first two fields specify the descriptor set to update and the binding. Yep. We gave our uniform binding index of 0. Remember the descriptors can be arrays, so we also need to specify the first index of the array that we want to update. We are not using an array, so the index is simply 0. And then descriptor write descriptor type description. We need to specify the type of the descriptor again. It's possible to update multiple descriptors at once in an array, starting at index destination array element. The descriptor count field specifies how many array elements you want to update. Okay, so this is type uniform buffer. And we just set the buffer info to this. The last field references an array with descriptor count. structs that actually configure the descriptors. It depends on the type of descriptor, which one of the three you actually need to use. The pbuffer info field is used for descriptors that refer to buffer data. Pimage info is used for descriptors that refer to image data, and ptexo buffer view is used for descriptors that refer to buffer views. Our descriptors is based on buffers, so we are using pbuffer info. So used for descriptors that refer to buffer data, image for the ones that refer to image data, and texo buffer for buffer views. Understood. Good. The updates are applied using BK update descriptor sets. It accepts two kinds of arrays as parameters: an array of BK descriptor set, an array of BK descriptor set. The latter, wait, what? Oh, BK write and BK copy. The latter can be used to copy descriptors to each other as its name implies. Okay, now this is so complex, but we just need to write. So which field is that? Descriptor write count and descriptor set, and then descriptor copy count and descriptor descriptor set descriptor copies. We're just setting, so that's it. Using descriptor sets. We now need to update the record command buffer function to actually bind the right descriptors set for each frame to the descriptors in the shader with BK command line descriptor sets. Then this needs to be done before BK command draw indexed call. So, first of all, we need to call this function, which we are, right? Init Vulkan. And then create descriptor sets. Okay. And then we need to go to record, command buffer. And on here, we need to bind the descriptor sets. Oops. We are binding the index buffer here. I guess I'll do it right after this to keep it clean. Before draw indexed, yeah, of course. Render pipeline layout, render dot data, and this is also in here. No U32 as this, and indices dot length. Oh, I don't have this, so I need to do. I'll add 6 like we had before. And just add this to do, and I'll fix it later. Yeah. Unlike vertex and index buffers, descriptor sets are not unique to graphics pipelines. Therefore, we need to specify if we want to bind descriptor sets to the graphics or compute pipeline. Makes sense? Wait, what am I doing? What did I copy? I want to do it here, and then I want to... Oh, because I thought this was 2 lines. Right. So just bind it, and that's it. programmer for games. What's up? All good? You? Okay, so that's the bind part. The next parameter is the layout that descriptors are based on. The next three parameters specify the index of the descriptor set, the number of sets to bind. We will get this in a moment. Where is that exactly? Descriptor count here is the second, third, fourth, fifth. Right. So it gives this BK pipeline bind point graphics. Then you give it the pipeline layout 0 as in layout. Wait, as in first set. Descriptor count, which is 1. The descriptor, dynamic offset, and whatever else. If you run the program now, you'll notice that unfortunately nothing is visible. First of all, let's check it. I feel like something has to fail. I'll save all of this just in case. Yeah. Okay. It's failing at somewhere, but I don't know why. Because this is at rasterizer, and I'm doing. The problem is that because the Y flip we did in the projection matrix, the vertices are now being drawn in counterclockwise order instead of clockwise order. This causes backface culling to kick in and prevents any geometry from being drawn. Go to the graphics, modify the front face to correct this. So front face needs to be this, which I get it. But then call mode, it's BK call mode backbit, which I'm not setting because I don't want backface culling for now. But then it breaks. Record command buffer. How about if we do it right on here. This is the same. No, let's see. Okay. At least we get an error this time. I'm doing it right before draw indexed. I'm giving it the current frame. Yeah, looks correct. Then make it dynamic. Right. I'm not sure. BK map pp data is no. Okay, that's better. So let's look at the code on create uniform buffers. Okay. So buffer size is size of uniform buffer object. Then we set the uniform buffers memory and uniform buffers mapped to max frames in flight. We for loop through that, and we create a buffer based on current uniform buffer and current uniform buffer memory. After so, we bk map memory uniform buffers memory, yeah, 0 buffer size and uniform buffers mapped to data I. I don't know, let's do uniform buffer mapped. What? Buffers mapped. And then just use that. Like, does that change anything? Also, I'm wondering why didn't I have that error? Oh, right, because this is void pointer. Yeah. Why am I not getting the error from before now? PP data. So I don't think this is incorrect, right? I mean, do we have to give it a pointer? Like if I do this current buffer, yeah, I do this dot data I, and then of course again we do this dot data I, and finally on here we do the same thing. This is memory. We don't need a pointer, and uniforms mapped. We just do it like this. I feel like this could be the error because I'm given not a pointer to the actual place in memory. It could be. Okay, it created a window and then it failed. So that's better. Yeah. Could it be the order? Init Vulkan. So init Vulkan. Here we do descriptor layout before graphics pipeline. Descriptor. Yeah. Then after uniform buffers we create pool and sets, which is done correctly as well. Then what else? We need the uniform. Okay. we create this uniform buffer here, and that's it. I mean, that order is correct. Okay, let's go for descriptor. Let's go by order. First we create the layout. Set layout. Oh. Descriptor set layout. But we're doing descriptor, create descriptor layout. Does that have to do anything with it? No, it's the same thing. But we should change the name. Descriptor set layout. So set this, and here we save that. Okay. This creates the UBO layout binding. Set it to 0. The descriptor count is 1, doesn't really matter. Then BK descriptor type uniform buffer, and then it says sets this to no pointer, but I'm guessing this is optional. Optional, no. Yeah, this is only used on the vertex shader, and the layout info is that we create the descriptor, and if it fails we show that there. Okay, so that is correct. This is create descriptor set layout. After that descriptor, we need to create the descriptor pool. So descriptor pool here, go to descriptor pool. We do pool size is 0, type is that, and we use max frames in flight like always. Give it pool info, descriptor pool create info, pool size, and max frames in flight, same as this. And then we create this descriptor pool, give it the pool info, null, and the descriptor pool. Good. And then we create the descriptor sets, which is the same thing that we're doing here. So first of all, we create a vector of BK descriptor set layout, and we resize it and populate it. Then we create BK alloc info, give it this set type, descriptor pool, the max frames in flight, and the layout data. Then we resize descriptor sets to max frames in flight, of course. And then finally we allocate descriptor sets with alloc info and give it the data, check that it's successful, and go to the next thing. We do buffer info, uniform buffers. Oh, yeah, never mind. Uniform buffers, and set it to I. We have no offset, and give it the size of uniform buffer. It's only 1, so yeah. Descriptor write, BK structure type write descriptor set. give it the descriptor set, destination binding in 0, bk descriptor type uniform buffer, descriptor count is 1, and that's buffer info. And then we finally create the descriptor set for that one. Then finally, wait, why are we? I'm pressing Ctrl D and it's not working. Okay, whatever. Update uniform buffer. Maybe I'm doing something weird on here. So we use current time divided by 1000. Graph current time, get the period from current time and start time. UBO and rotate here, identity matrix. Why can't I give this directly? And what does this do? Right, so we can't use it because it's not like this. But okay, so GLMS mat for identity init o. Could we use that? Yeah, that's it. We don't need to save it anywhere, so anyways, give it that. The current time multiplied by radiant and back 3. Yep, they do it by Z. We can try only doing it by Z. Give it a view. We create that, and create that. Then check the perspective. We give it 60 degrees and multiply subchain by this. And we're good. And then do uniform buffers mapped data by current frame, give it the UVO and the size of it. Finally, by the way, I should restart the new UI because it's bugging. There we go. Finally, we need create descriptor set layout. Now we already did this. So we already checked this, and record command buffers would be done on another place. Record command buffers. Like before, we bind it here with the pipeline layout. Record command buffer. By the way, we're doing this before reset fences. Let's try doing it like that. I mean, I don't think it should change anything, right? Oh, I mean, update based on current frame. And then we record command buffer right after. Oh, maybe that's it. Yeah. That could actually be it. Anyways. In record command buffer, we do around the same thing. Just, oh, he adds everything at the end. Yeah, maybe let's do it at the end as well. Here we go. And this can be buffers, bind buffers. That stays the same. Vertex buffers, offsets, index, 0, BK type, yeah. Bind it on the graphics, give it the pipeline layout. Yeah, and the rest is the same. Apart from this, right? But we have 6 indices, so that should work. No, still no. Okay, how can I debug it? Because test 3 and right after this test 2. Let's see, where does it get? It doesn't get to any of those. Does it? Yeah. How about log info, update, whatever. And then, I mean, I feel like it's failing on create uniform buffer before, after. Yeah, it breaks on there. Just to make sure, I'm gonna rerun. Yeah. It's interesting that the validation error happens sometimes and then sometimes not. But whatever. So pp data must be a valid pointer to a pointer value. The thing is, what do you mean? So create uniform buffers, and when we are doing that, we already need uniform buffers. Yeah, that is resized. So what is pp data? Oh, nice. So maybe the documentation has something to say. Wait, what? pp data parameter, yeah. Where is it? pp data. Oh, it's the last one. It should be void pointer. right? This buffers mapped. It's also, I'm not sure what is the problem. I mean, I'm setting it to void pointer, no? And it's a pointer to, oh, there we go. Oh, that was it. I was forgetting to update that. Okay. Good. Yeah. Let's get out of that. Create it again. Oh, we still have test 3 here. Okay. Now it should work without any problem. Good. And we're getting could not find descriptor set layout. This should not happen and may indicate a bug in the application. BK destroy descriptor set layout. Okay. Oh, maybe destroy descriptor set layout. Oops. I'm already destroying it before. Yeah. This should be before the pipeline, no? Okay, there we go. Also, let's test. So this U32 size of indices divided by size of indices pointer. Let's see. Okay, that works too. And I wanted to also what was it? Rotate around this too. Yeah, kind of like that. Okay, that, and I also want to have a square, so learn OpenGL. Where is it? Okay. Oh, no, not what we want. Source code. Yeah, this vertices, and does it indicate the indices? Oh no. Yeah, because we're doing GL draw arrays there. Also, what is this? These are the colors, no? Yeah. Okay, I don't know how you would do it with indices. Box, triangle with indices. Maybe someone did it. No. I'll do it later. The rectangle has changed into a square because the projection matrix now corrects for the aspect ratio. The update uniform takes care of screen resizing, so we don't need to recreate the descriptor set in recreate swap chain. Let's see. Yeah. One thing we have glossed over is how exactly the data in the C++ structure should match the uniform definition in the shader. It seems obvious enough to simply use the same types in both. Yeah. However, that's not it at all. For example, try modifying the struct and the shader to look like this. So here you need to add offset of 2. Recompile your program and run it, and you'll find that the colorful disappeared. That's because we haven't taken into account the alignment requirements. Vulkan expects the data in your structure to be aligned in memory in a specific way. For example, blah blah blah. You can find the full alignment requirements here. It's basically just 16 all the time. Our original shader with just 3 mat4 fields already met the alignment requirements, as each mat4 is 4 by 4 by 4, which is equal 64 bytes in size. Model has an offset of 0, view has an offset of 64, and projection has an offset of 128. All of these are multiple of 16, and that's why it worked fine. Yes. The new structure starts with bec2, which is 8 bytes. Whatever, you can just use align s 16. That's interesting. A bit cleaner, I guess. The only bad thing is like you have to put it on the next one, because if not you could create a macro that aligns this directly. If you compile and run your program again, you should see that the shader correctly receives its matrix values again. Luckily, there's a way to not have to think about these alignment requirements most of the time. You can define GLM force default align gen types right before including GLM. Yeah, I'm not gonna do this. This will force to use a version of bec2 and mat4 that has the alignment requirements already specified for us. If you add this definition, then you can remove the align as specifier and your program should still work. Unfortunately, this method can break down if you start using nested structures. Consider following definition in C++ code. Right. And the following the shader definition. I mean, just don't do this. Yeah. These gotchas are a good reason to always be explicit about alignment. That way you won't be caught off guard by these strange symptoms of alignment errors. Don't forget to recompile your shader after removing the foo field. Can I... So where is the UBO? UBO. Right. Here. Can I add this? Where do I import it from? I remember align as in C. I remember there. Oh, it's underscore. Interesting, but can you just do define? It a paste bin for the cube IDX. I mean, if you find one, send it. align. Oh, what am I doing? Align size and then align as size. Yeah, and you just do align 16 for each. Would that work? Okay. Yeah, I guess I'll add this on render since it's gonna be useful. Align is since C11 and then deprecated. Oh, because you can just have this. I guess that chat. Yeah, I was streaming before, but my connection went out and I don't know what happened. Chat died. Let me see. Pagestream.com, I'm guessing. This page is no longer available. It has expired, been removed by its creator. What was I going to do? Here, first of all, can I get some intelligence here? Optimization. Flags. Well, what happened? Like I can't. Oh, because it closes here. My bad. Flag optimization. What is it? Yeah, that's for nothing then. Warnings. Flag. Warnings. Minimal. Or just warnings. What is this? Well, an extra. Yep. DT. This and std flag std C23. Okay, if I do that, and then I try to use align as, it doesn't work either. Well, whatever, I'll just keep it like that. I think align as should work. Maybe it's not implemented on the version of C23 I'm using. Multiple descriptor sets. A sum of the structures and functions calls hinted at. It is actually possible to bind multiple descriptor sets simultaneously. You need to specify a descriptor layout for each descriptor set when creating the pipeline layout. Shaders can then reference specific descriptor sets like this. You can use this feature to put descriptors that vary per object and descriptors that are shared into separate descriptor sets. In that case, you avoid rebinding most of the descriptor across draw calls, which is potentially more efficient. Alright. What do we do here? This is the same as in OpenGL. Okay, let me close all of this. I mean, if I use this, what is this, by the way? The UB? Yeah. Right. So I would need to use XYZ and the UV. Or is it? Where is the shader? Vertex shader. APAS. Oh, text chord, right. Yeah, I don't know, I'll keep it like this for now. Anyways, I'll take a break now, go eat something, and I'll continue later. Maybe I stream it, maybe I don't. Probably not. So I'll see you guys today or tomorrow. See ya.